In a move that has stunned parts of the aviation world, Russia has unveiled a powerful new engine, the GTD 110M. This engine is more than just another technical upgrade. It signals something far bigger. Russia is not only pushing forward in aviation technology, it's doing so with a level of independence and innovation that many in the West didn't see coming. The GTD 110M is a high-performance gas turbine engine originally designed for power generation. But its development is now sparking serious conversations in both civilian and military aviation circles. That's because the core technology behind it could be used in a wide range of advanced aircraft, especially at a time when Russia is being cut off from many Western aerospace components. So why is this such a big deal? In this video, we'll break down 4 powerful reasons why the GTD 110M is turning heads, and what it could mean for the global aviation industry. Let's get into it. Technological independence. One of the biggest reasons the GTD 110M matters is simple. It's built in Russia, by Russia, for Russian needs. For decades, Russia's aviation and aerospace industries relied heavily on foreign parts, especially when it came to high-end engine components. In fact, many of the gas turbines and jet engines used in Russian aircraft were either based on old Soviet-era designs or dependent on Western suppliers for critical parts. But sanctions and export bans have changed everything. In recent years, Western nations, including the United States and countries in the European Union, have placed strict limits on what kinds of technology can be exported to Russia. That includes advanced engine parts, software, and precision tools. As a result, Russia had to make a choice: fall behind or catch up fast. The GTD 110M represents the second option. Developed by Russian engineers under the company ROSTEC, this engine is the first high-power gas turbine of its kind, fully developed and manufactured domestically. That means no dependency on outside tech, no waiting for foreign approval, and no risk of having the supply chain shut down by outside forces. This is a major strategic win for Russia, not just in aviation but in technology overall. And it's not just about survival, it's about pride. Being able to design, test, and build your own engine means you're back in control. It gives Russian aerospace developers a new level of freedom to experiment, to iterate, and to innovate without outside interference. In the global aerospace race, that kind of independence is rare, and it's exactly why this engine is making headlines around the world. Advanced performance metrics. If the first reason was about independence, the second is about performance. And the numbers behind the GTD 110M are impressive. This engine is designed to deliver over 110 megawatts of power in its current gas turbine format. While that's typically used in power plants, the core technology, including the turbine design, thermal efficiency, and fuel management system, is now being considered for use in advanced aviation platforms. Let's break that down. The GTD 110M uses a high-efficiency turbine core built to operate in extreme conditions, including sub-zero temperatures and continuous high-load cycles. Engineers claim that this engine delivers improved thermal efficiency, reduced maintenance needs, and longer operational cycles than previous Russian designs. That alone is a leap forward. But what's even more shocking is how closely it now compares with engines from the West, like the General Electric LM2500 or the Rolls-Royce Trent 1000 series. Those are gold standards in modern aviation and power generation, and for the first time in years, Russia is producing something that's being mentioned in the same breath. The engine's durability has also been highlighted. It can reportedly run for 25,000 hours before needing major servicing, which rivals some of the most reliable engines used in commercial aviation today. It also boasts lower specific fuel consumption than earlier Russian turbine models, meaning it burns less fuel for the same amount of power, which is critical in both military and commercial aircraft applications. What does this mean for aviation? If this technology is adapted or scaled into military transport planes, drones, or even future wide-body aircraft, it could allow Russian aerospace companies to build more fuel-efficient, longer-lasting aircraft without relying on imported engines. And that's the kind of performance boost that could close the gap with global competitors faster than many expected. Strategic military applications. One of the biggest surprises behind the GTD 110M engine is its potential role in the military. And that's reason number 3. Originally designed for energy infrastructure, this engine is now being viewed through a completely different lens by Russia's defense sector. That's because the same qualities that make it excellent for power generation, high thrust, fuel efficiency, and long-term durability, also make it a candidate for powering military aircraft and naval systems. According to analysts, Russian defense planners are already considering how the GTD 110M could be used in heavy transport aircraft, large military drones, and even naval vessels like frigates or destroyers. Let's start with aircraft. Russia's military has long relied on older engines, many of which were inherited from the Soviet Union. These engines are known for being loud, fuel-hungry, and high maintenance. Replacing them with something more modern, like a modified version of the GTD 110M, would give Russia's air fleet a major upgrade in both range and reliability. It's also about stealth and endurance. If an aircraft can fly longer without refueling or make less noise while doing it, it becomes harder to detect and much more effective in combat or surveillance missions. But the applications don't stop with the air. There's growing speculation that this engine, or at least its core technology, could be adapted for marine propulsion systems. Russian warships have faced delays in recent years due to a lack of modern engine parts. A home-built power plant like the GTD 110M could change that. Bottom line, this isn't just a civilian breakthrough. This engine could help modernize key parts of Russia's military and do it without relying on any foreign suppliers. That makes it a strategic asset that goes beyond the runway. Economic and geopolitical implications. The fourth and final reason the GTD 110M is sending shockwaves through the aviation world isn't just technical, it's political and economic. Let's start with economics. Building an engine like the GTD 110M entirely within Russia means that more money stays inside the country. It creates jobs, boosts the domestic supply chain, and reduces the billions Russia once spent importing high-tech parts from other countries. In a time of sanctions and restricted trade, that's a massive win. It also sets the stage for export opportunities. If this engine proves reliable and adaptable, Russia could sell versions of it to countries that are cut off from Western suppliers. That includes nations in Asia, Africa, and the Middle East that are looking for alternatives to the usual Western-made power systems. From a geopolitical angle, it's even more interesting. The rise of the GTD 110M fits into a larger pattern. Countries like Russia and China are trying to become technologically self-sufficient. They're building their own ecosystem so they can resist economic pressure from the West and still grow their industries. That has ripple effects. If more nations start adopting or copying this kind of technology, we could see a splintering of the global aviation and defense markets, with one camp led by the United States and Europe, and another led by Russia, China, and their allies. This kind of divide might slow down international cooperation in aviation development. It could lead to regional engine standards, regional supply chains, and more competition over emerging markets. And all of that starts with engines like the GTD 110M. It's not just a machine, it's a symbol of independence and a challenge to the current world order in aerospace. The future of aviation power. To wrap it all up, let's go back to the big picture. The GTD 110M engine is a technical achievement, but more importantly, it's a strategic signal. Russia is telling the world that it no longer needs to rely on Western technology to compete in the aviation and defense industries. With this engine, it's pushing for self-sufficiency, improved performance, and stronger military capability, all while changing the economic and political balance in global aerospace. So why is this engine shocking the aviation industry? Because it proves that Russia still has the resources, the talent, and the will to compete, even under pressure. It's a bold move and one that could shape the next decade of aviation power. We'll be watching closely to see just how far this engine and the country behind it can go.